And I also think that in all of your schools, they have taught rational numbers. So you must have naturally wondered that why are they calling numbers rational all of a sudden? Which numbers are considered to be rational numbers? Since the name of the chapter is rational numbers, it might even suggest that there are numbers that are not rational. Maybe. But to answer or even discuss those questions, we must first clearly understand what are rational numbers. So, would anybody like to tell me what are rational numbers?
Sir, rational
Okay.
numbers are the set of numbers which are the maximum, means which contain all the integers and are maximum. They contain fractions also and they contain decimals also.
Okay, by
Yeah.
the way, first of all, decimals and fractions, they are the same kind of numbers. Okay, they're not different numbers. But what you're saying is not so wrong. But I want to hear from everybody. So, anybody else also wants to tell me what are rational numbers? Which numbers are rational? If I write a few numbers on the screen, 7, is this a rational number?
Yes, sir.
Everybody will say, yes, this is a rational number. And why is it a rational number, by the way?
Sir, because it is in the form P by Q.
It can be written in the form P by Q. Is that what you're saying?
Yes, sir.
So, how will I write it in the form P by Q?
7 by 1.
7 by 1, or I may also write it as 14 by 2, or I may write it as 700 by 100. But I can write the number 7 in the form of something divided by something. And that is why we are saying that 7 is a rational number, isn't it? So maybe what you people are trying to suggest is that any number that can be written in this kind of format, something divided by something, such a number will be considered as a rational number. Is that what you're suggesting?
Sir, rational numbers are in P by Q form and Q should not be equal to 0.
And P and Q should also be integers. That is also
Yes, sir.
mentioned. Right? Okay, great. So you people do have some idea about what are rational numbers, but I would like to take you back to the very beginning of numbers. Of course, we are also going to get to the point where we are discussing rational numbers particularly. But before that, I would like to talk about numbers in general. ठीक है तो rational भूल जाओ. Think about numbers alone. What do you think are numbers? Why do you need numbers? Of course, numbers are necessary to the society, isn't it? But why do you think we need numbers? What is the reason that we need numbers?
So to know exact amount of a thing.
Okay, so to count basically, to quantify things, right? To know the quantity of certain things.
Yes, sir.
Like right now, if I asked you, how many fingers do you have? Unless you have numbers in your vocabulary, you won't be able to answer the question back to me, right? You might want to express your answer without numbers. You can, if you didn't use numbers, you will probably say, sir, I have some fingers. But some does not tell me how many. If I could be imagining 3 fingers or 15 fingers when you say some fingers. So numbers are important to quantify things, correct? Now, in order to quantify things, people, the earliest people, okay, so if you go like 10,000 years back, the earliest of the earliest people came up with the most natural numbers, meaning numbers that would allow you to count things. See, if you go back 10,000 years, then people had a very simple life. Okay, society was not very complex. And the only job of numbers was to probably count the number of trees, to count the number of eggs, to count the number of people in a certain village. And for that, they introduced natural numbers because they felt that these numbers are naturally required. Okay. And what are natural numbers? Examples of natural numbers are 1, 2, 3, 4. We also call them counting numbers. Natural numbers are also known as counting numbers, right? So 1, 2, 3, 4, 5, etc. They fall under the category of natural numbers. I'll also write it like this. Natural. And nobody needs to copy down anything unless I tell you to. Okay, don't need to copy. Natural numbers. Okay. Now imagine one day you were going to the market and you bought 5 oranges. But while returning back home, a thief came and stole some of them. Okay, stole 2 of them. So you went straight to the police station and the policeman asked you to fill out a form and asked you to state how many oranges you have bought and how many are left with you. So in that form, in the box where you had to fill how many oranges are left, today you could fill that there are 3 oranges left, right? And you could fill this box because you have invented the number 3. It is a natural number. But some other unfortunate day, suppose you bought, let's say, 7 oranges, and while coming back to your home, all 7 of them got stolen. Now when you go to the police station and ask how many oranges, and you have to fill in the box that these I had bought 7 oranges, and now you have to fill how many oranges you are left with. What will you fill in the box? You bought 7 oranges and all 7 of them got stolen. So what are you going to fill in the box? That how many oranges are left? So the problem is that now you people would exclaim, sir, 0 oranges. But people back then who had only invented the natural numbers did not have this number in their vocabulary. Then they realized that to express nothingness or the absence of any quantity, we must invent a number, and that is how 0 was invented, right? So after inventing 0 and putting 0 into the set of the already existing numbers, people have now formed a new family of numbers. This new family of numbers is called what?
Whole numbers.
Whole numbers. Very good. Whole numbers. So what are whole numbers? Whole numbers is the family of numbers that include all the natural numbers and also include 0. Correct? But do you think that only whole numbers will be able to express all kinds of quantities?
No,
Well,
sir.
soon people realize that it cannot. Suppose you bought 4 chocolates and you distributed the 4 chocolates among 2 kids, kid A and kid B, and you distributed it equally. So how many chocolate will each kid get?
2.
Obviously 2 chocolates. Now here you could answer the question because 2 is a whole number. But imagine that you had to distribute it among 3 kids. Now how many chocolate will each kid get? 4 chocolates hai. You want to distribute it equally among 3 kids.
1.333333.
So first of all, people at that time only had whole numbers to deal with. They did not have any other kind of number. So can they use whole numbers to express how many chocolates each kid got? Just using whole numbers. Like if you were in their place and you had to tell me somehow how many chocolates A got, what will you tell me? How many chocolates did A get? Did A get 1 chocolate?
No, sir.
Did A get 2 chocolates?
No, sir.
So you will say that A got somewhere between 1 and 2 chocolates, isn't it?
Yes, sir.
Notice in this statement I am making use of only whole numbers in my statement. But the problem is that when you say that A got somewhere between 1 and 2 chocolates, it does not really express an exact amount of quantity. I might imagine that A has got 1 full chocolate and then just a tiny particle. This is also more than 1 and less than 2. Or I could imagine that A got 1.5 chocolate. Or I could imagine that A got 1 and almost a 2 but just slightly less than 2. So saying that A got more than 1 but less than 2 is not enough. So at this point, what did people do to express this kind of a quantity? They came up with what we call as fractional numbers, fractions. And they didn't even think much. They came up with a very simple kind of notation. Bole ki bhai, each kid will get, just write the total number of chocolates that is getting distributed, put a horizontal line, and below that write among how many parts are we distributing. This in itself became a number. Okay, people back then felt very uncomfortable to accept this as a number. Up till now, they were only accepting these numbers as numbers. But now, even this is a new kind of number that they had to accept. That 4 by 3 is a new kind of a number. It is a fractional number. Alright. Now, I don't have to tell you about fractions that much. You people are in class 8 now. You know fractions can be proper, improper. You can write improper fraction in mixed formats and all that. Today, the point is only to talk about the kinds of numbers, the types of numbers. Okay. So, this was the invention of fractions. Now, we know that there are natural numbers. To that, we also included zeros. So, we had the set of whole numbers. And to that, we have also now put some fractions like half, okay, 3 by or 4 by 3 or 5 by 2. And this family of numbers, is it given any name? Not really. We can call it wholes and fractions. Wholes and fractions. Are these numbers enough? For the society, are these numbers enough?
No, sir.
No or yes? No. Why not? When have you felt a requirement for any other kind of number? Growing up, you people are now what? 14 years old or 13 years old?
No, sir, 12.
12. So you people have lived 12 years of life. Where have you felt the need of any other kind of number? बाजार में गए, बोले कि भाई मेरे को 5 चॉकलेट खरीदना है, तो 5 is a whole number. You already have invented it. Shopkeeper said the price of each chocolate is rupees 10. 10 is also a whole number. Total cost 50. That is also a whole number. Brought these 5 chocolates back home, distributed it among 3 people. Each person will get how many? 5 by 3. That is also a number that is invented. So it seems as if we are not even requiring any other kind of number, isn't it? And very honestly speaking, me also personally, I have lived more than twice your life, but I also never felt the need for any other kind of number. And we should not feel bad about it. Because if we look at the history of numbers, even the humankind did not need any other kind of numbers for a very long time. मतलब नेचुरल नंबर्स इन्वेंट हुआ, उसके बाद जीरो इन्वेंट हो गया, उसके बाद फ्रैक्शंस भी इन्वेंट हो गया, उसके बाद बहुत 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 साल तक और कोई भी अलग टाइप का नंबर इन्वेंट नहीं किया गया, क्योंकि जरूरत ही नहीं फील हो रहा है ना. Today you can lead a full healthy and good life, and your life will also end, but you'll never really feel the need of any other kind of numbers, right? But you being students of maths, you know that there are some other kinds of number. Can you give me an example of a number which does not fall in any of the categories that we have written so far?
Sir, 0 plus. 0 plus.
0 plus, chalo theek hai. Any other number?
Irrational numbers.
Integers.
Give me the example of a number, exact number.
-1.
-1. Very good. -1, -3. The moment you went to class 4, 5, 6, they started telling you about these numbers. But did you people really think about what is this sudden weird -1 kind of number? Why are we talking about it? -3, -2. Why do we need it? अभी तक उसके पहले तक तो it is very good. All these numbers that you're studying, you're needing it. They're expressing some quantities. Suddenly -1, what is it expressing? Is it really expressing a quantity? Could it express a quantity? Why did people invent it? At this point, when people had already invented wholes and fractions, what kind of quantity could they not express using wholes and fractions, that they felt the requirement to invent other kinds of numbers? This is a very important question to think about, isn't it? So let me put you in a certain situation. Okay? Everybody will listen to me very carefully. These were doubts that somebody had, Kanav had. Let me remove these pages. All of you can see the screen, right? I hope all of you can see the screen.
Yes, sir.
Okay, very nice. So now I want all of you to imagine that there are two friends. Two people, Mr. A, Mr. B, they're friends. And they go to and both of them are going to the market. Okay. And friend A had rupees 400 in their wallet, and Mr. B had rupees 500 in his wallet. Okay. They are these two people. Now both of them, when they went to the market, maybe they went to a toy shop and they got interested in buying a certain toy. Both of them got interested in buying the same toy. Maybe it's a teddy bear. Okay, both of them got interested to buy the same toy. Exact same toy. And there are multiple pieces of the toy. And suppose, imagine that the cost of the toy was, as a tag pe laga hua hai, that the cost was rupees 500. Okay. So who can afford to buy this toy between
B.
Mr. A and Mr. B? Mr. B can afford to buy the toy. However, Mr. A, because he was very keen on buying the toy, he was very interested in buying the toy, decides to strike a deal with the shopkeeper. He says that, listen, today you take my 400 rupees, give me the toy. Whenever I earn more money, I am going to repay you the 100 rupees back. As and when I earn more money, I'm going to return you the money back. Now the shopkeeper sees that, okay, it is an opportunity to sell the product, sell the teddy bear, right? And somehow he trusts Mr. A and decides to give Mr. A the toy. So Mr. A has brought back the toy, and obviously he has spent the 400 rupees and given it to the shopkeeper. And Mr. B has also purchased the toy, and Mr. B did not have to strike any such deal with the shopkeeper because he had the 500 rupees to buy the toy, right? Now my question to you is, after coming back, both Mr. A and Mr. B compare their wallets. Okay, they're looking into their wallets. All of you will agree that both Mr. A and Mr. B find their wallets to be empty. Correct? But does that mean that Mr. A and Mr. B are at equal financial situation?
So,
Who do you think right now is poorer, Mr. A or Mr. B?
A.
Mr. A is now at a worse condition, at a poorer condition. Why? Because the next day, when Mr. A and Mr. B go out and do their work, suppose Mr. A and Mr. B, both of them are paid rupees 10. Now that rupees 10, Mr. B can comfortably keep in his wallet, but will Mr. A be able to keep it in his wallet?
So,
No, he has to repay that 10 rupees back to the shopkeeper. Isn't it? So even after earning 10 rupees, the wallet for Mr. A is going to still remain empty. So when Mr. A and Mr. B had come back from the shop, and when they had compared their wallets and found that their wallets are empty, would it be correct to say that Mr. A, Mr. B ke liye to we say that Mr. B is currently worth 0 rupees. But is it correct to say Mr. A is also worth 0 rupees at this moment?
so,
No, sir.
No. We can't say that Mr. A is also worth 0 rupees, because somehow Mr. A is even worse. The next day, if he earns 10 rupees, still he won't have any money in his wallet. Meaning the amount of money in his wallet kind of seems to be even less than 0. he will have to, it's almost like if he earns rupees 110, then in his wallet he'll only be able to keep rupees 10 because the 100 he has to repay back to the shopkeeper. It's almost like the starting balance for Mr. A is 100 below 0, 100 less than 0. For Mr. B it is 0. That is why if he earns 110 rupees, he'll be able to keep all that 110 rupees in his wallet. But if Mr. A earns 110 rupees, he'll only be able to keep rupees 10 in his wallet. Almost like his wallet balance will start 100 behind 0. He has to climb that 100 first, and then only he can start putting some money in his wallet. Correct? At this point, if we had to answer how much money does Mr. A have and B have after making the purchase of the toy, what should we correctly say? Mr. B, we can say, has 0 rupees after buying the toy, but Mr. A has something which is 100 less than 0. But this is not a whole number or a fraction that we know now. At least the people back then, they don't really have any number to express such a quantity. They are shocked that we have faced a situation where the quantity has become less than 0. And let me tell you, this only happened after the advent of money. जब तक दुनिया में पैसा नहीं था ना, नेगेटिव नंबर्स का जरूरत ही नहीं पड़ा था. After the world and society civilized, transformed and evolved to the point that there was money, market, lending, borrowing, only then the concept of negative quantities came into play. उसके पहले तक था ही नहीं negative quantities का concept. And now you people obviously know that we invented these numbers. So if we have to express a quantity which is 100 less than 0, how do we write that quantity? We say, we put a horizontal line and then write 100. This is a new kind of number. Again, people had a hard time accepting this as a number. But it was then established that this is also a number. This is a number that is less than 0. In fact, how much less than 0? It is 100 less than 0. Such a number is called a negative number. Right? So then came the invention of negative numbers. So fractions to tha hi, wholes tha and fractions tha. So similarly we'll have negative wholes and negative fractions like negative 5 by 3, negative 1, negative 6, negative 11 by 4 and so on. So isko we can call it negative numbers. At this point, there is a special name that you should know. If you consider only the positive wholes, the negative wholes and the number 0. Negative wholes, positive wholes and the number 0. मतलब कि ऐसा. This family of numbers is given a special name. This is not a new family of number. I'm just saying that this family of numbers is given a special name. What is it called?
Integers.
Integers. So integers does not include any fractions. Although it includes negative numbers, but it does not include any fraction. Okay? Understood? So tell me if all of you are clear with what are natural numbers, whole numbers, fractions, negative numbers and integers. Is everybody clear with this? Ashwika, you are attending my class for the very first time. I hope you are able to follow what I am saying.
Yes, sir.
Everything so far?
Yes, sir.
Wonderful. So all of you, I hope, are very clear till now. Okay? Next, we have now even come up with a number that expresses quantities less than 0 somehow. Do you think there can be any quantity that cannot be expressed by all of the numbers that we have invented so far?
Yes, sir.
ऐसा भी कोई situation हो सकता है क्या जहां पे we encounter a certain quantity which we are not able to express in either a whole number or a fraction or any negative number?
Sir, I don't know about a situation, but there is a number which we cannot represent by these.
But numbers are only invented when there is a requirement. तो पहले तो we have to understand if there is any requirement. रिक्वायरमेंट नहीं होगा तो नंबर बनेगा भी नहीं, क्यों बनाए बेकार का। नंबर्स बनाने में थोड़ी इंसान को मजा आता है देयर हैज टू बी सम काइंड ऑफ रिक्वायरमेंट फॉर दैट नंबर। हर नंबर देखो कोई ना कोई रिक्वायरमेंट से ही बनाए, इसीलिए नेगेटिव नंबर्स का इन्वेंशन बाकी सारे नंबर्स के बहुत बाद में हुआ, बिकॉज उसका रिक्वायरमेंट ही बहुत बाद में आया। तो इट इज इंपॉर्टेंट टू आंसर द क्वेश्चन कि ऐसा कोई भी सिचुएशन है क्या जहां पे ना ही नेचुरल नंबर, ना ही होल नंबर, ना ही फ्रैक्शन, ना ही नेगेटिव नंबर से हम लोग एक्सप्रेस कर पा रहे हैं उस क्वांटिटी को। ऐसा सिचुएशन हो सकता है क्या? तो तुम लोग बोलोगे सर हम लोग तो नेगेटिव नंबर का भी सिचुएशन जरूरत नहीं आ रहा था, आप तो इसके भी आगे का पूछ रहे हैं, है कि नहीं? सही बात है। तो अगेन आई वुड लाइक टू पुट यू इन अ सिचुएशन, ओके, and understand the situation very carefully. Again, put yourself back in ancient times. अभी तुम लोग निकले हो जमीन खरीदने, ठीक है? And suppose the land that you are going to buy is a square piece of land, and the area where you have gone to buy the land, the city or whatever kingdom where you have gone to buy the land, the rate of the land is, let's say, rupees 10 per square feet. You people might know that square feet is a unit of area, and usually when you are buying property, small property at least, you will be measuring the size in square feet, right? So you went to a particular land and you saw the price tag on the land and saw that the price tag said rupees 810, ठीक है? And the rate, you know, the rate is rupees 10 for every square feet, per square feet. And the price tag on the land is rupees 810. Can you tell me? So you're just calculating that, okay, if I buy this land, I will have to fence the front portion. So you're probably asking yourself, what is the length of the fence that I will have to buy? So can you tell me what must be the length of the fence or the length of the front side of this square?
Sir, 9.
9 what?
Sir, 9.
Sir, 9 feet.
9 feet. 9 feet. Is everybody following that? Let's go step by
Yes,
step. Let's go step by step. What must be the area? Ashvika, can you tell me what must be the area of this square field so that the price of the square field becomes 810? What must be the area?
Sorry, sir.
What must be the area of the square field such that the price of the square field becomes 810? It is known to
Sir,
us that
81.
81 square feet. So
Yes,
if
sir.
the area of the square land is 81 square feet, what must be the side length?
9.
9, very good. Okay. So I'll keep asking this question again and again for different values of the land. Let's say the land was costing rupees 2250. Anybody can unmute and answer first. What will be the length of the side?
sir, 15.
15. Arjun has answered first. So the next one, Arjun can't answer. Well done, Arjun. If the square land costed 5120, then what will be the length of this? Not 5120. Let us make it 6250. Then what will be the length of the
Sir,
front?
25 feet.
25 feet. I will assume Kanav has answered this question. Well done, Kanav. So now Kanav and Arjun cannot answer. Imagine that it costed rupees 40. What will be the front side?
Sir, 2.
2 feet. Very good. Now Arjun, Kanav and Gaurav cannot answer. If it costed rupees 90. What will be the length of the front side?
Sir, 3.
3.
Sir,
3. Now, Ashvika, only you have to answer this next question. If it costed rupees 10, then what must be the front side? Length of the
sir,
front side?
1.
1, right? Because 1 square feet wala square, uska front side 1. Now, everybody is free to answer. Whoever can answer first. Okay? It is rupees 20. What will be the length of
Sir,
the
2.
front side?
Sir, 2.
Wrong.
Sir, square root of 2.
Yes, sir, root 2.
So
Sir, root 2.
let's first think about
Sir,
the
it will be
area.
in decimals.
Yeah, first tell me area. What will be the area of this square?
2
Centimeter
square.
square.
2
2
square
meters.
feet. This तो I think everybody can understand. क्योंकि तभी 10 से multiply करके the price will become 20. Now, if you have a square that has an area of 2 square feet, what will be the side length? This is the question. And it is an interesting question. It's a very difficult question, by the way.
Sir, it's root 2.
रूट 2 अब क्या हो गया भाई? वी हैव टेकन आवरसेल्व्स बैक टू द एंशिएंट पीपल और अभी अपने पास सिर्फ यही नंबर्स हैं. रूट 2 तो ऐसा कोई नंबर है नहीं अभी तक दैट वी नो ऑफ.
So you have to create a new one.
Wait, first we should not suspect that we'll have to create a new one. First we'll think कि भाई if there is a square that has an area of 1 square feet, then what will be its side length? 1 feet.
1.
If there is a square that has an area of 4 square feet,
Sir, 2.
then what will be its side length?
Sir, 2.
2 feet. Our particular square is having an area that is greater than 1 but less than 4. अपने वाले का है 2 square feet. So what must be the side length?
Sir, root
Between
2.
1 and 4.
मतलब somewhere between 1 feet से तो ज्यादा होना चाहिए
Yes, sir.
और 2 feet से कम होना चाहिए. पहला बात ये बताओ, सब लोग को समझ में आ रहा है ये बात
Yes, sir.
कि साइड लेंथ 1 feet से ज्यादा और 2 feet से कम होना पड़ेगा. तो एट दिस पॉइंट ऑल ऑफ द एंशिएंट पीपल एट दैट टाइम, और ये ज्यादा एंशिएंट का भी बात नहीं है वैसे, ऐसा नहीं है कि 10,000 साल पहले का बात चल रहा है. नाउ दिस इज ओनली अ मेयर 1500 years ago. Okay, that people started to face this question कि भाई इस स्क्वायर जिसका एरिया है 2 square feet उसका साइड लेंथ कितना होगा. तो पीपल रियलाइज्ड कि उसका साइड लेंथ 1 से तो ज्यादा होना ही पड़ेगा और 2 से तो कम होना ही पड़ेगा. बट दे वर नॉट स्कैर्ड बाय दिस सिचुएशन. व्हाई? 1 से 2 के बीच में जो नंबर्स आते हैं वो इन्वेंट हुआ है क्या अभी तक? हाँ, यस और नो?
Sir.
I can only hear sir. Actually, the first part is getting cut.
Yes,
during you.
sir.
Yes, sir. Yes. Why? Because we have invented what already?
Fractions and decimals.
Fraction. Decimals, forget. See, decimals is just another form of fractions. Decimals is not an other kind of number. ठीक है? Fractions को ही decimal के form में लिखा जाता है. So we have invented fractions. We know that between 1 and 2 we can describe numbers in the fractional form. Correct? Can you people give me an example of a fraction that lies between 1 and 2?
2 by 5. 5 by 2.
5 by 2 तो होता है 2.5. Brother, that is wrong. 1
Sir,
और
4 by
2 के
3.
बीच में fraction.
4 by 3.
4 by 3 is correct. So I'll give you a very simple way to do that. 1 को I can write it as 2 by 2. ठीक है, मतलब I am choosing the denominator to be 2. तो 2 को what can I write with the denominator 2?
4 by 2.
4 by 2. अब 2 by 2 और 4 by 2 के बीच में एक फ्रैक्शन बताओ. 3 by 2. तो 3 by 2 will become a fraction that lies between 1 and 2. Agreed? Now what if I make I want to write 1 and 2 but with the denominator of, let's say, 7. So what will 1 be written as? 7 by 7. And what will 2 be written as?
14 by 7.
Now, so what will be the fractions that lie between 7 by 7 and 14 by 7?
10 by 7.
10 by 7. ये सारा ही बताओगे तो 8 by 7, 9 by 7, 10 by 7, 11 by 7, 12 by 7, 13 by 7. All of these numbers are between 1 and 2. You agree? So here I have a very important question to all of you. How many fractions do you think can lie between 1 and 2? How many?
Sir,
Infinite.
infinite.
Infinitely many. कोई लिमिट ही नहीं है भाई. I can make the denominator 100. 1 को बोल दिया 100 by 100, 2 को बोल दिया 200 by 100 और शुरू हो गया 100 1 by 100, 100 2 by 100 करते करते 99 नंबर्स बता दिए. राइट? डिनोमिनेटर 1000 बना दो, मिलियन बना दो, ट्रिलियन बना दो. There is no limit on how many fractions you can find between 1 and 2. तो इसी बात से ना उस समय के एंशियंट लोग बिल्कुल भी नहीं घबराए. बोले कि ओके दिस आंसर इज समवेयर बिटवीन 1 and 2. डोंट वरी, वी हैव इनफाइनाइट ऑप्शंस टू चूज फ्रॉम. कोई ना कोई एक वैल्यू तो होगा ही ना 1 और 2 के बीच में. देयर मस्ट बी सम फ्रैक्शन बिटवीन 1 and 2 दैट विल एग्जैक्टली बी इक्वल टू दिस साइड लेंथ. Isn't it? So they started trying fractions. 1 and 2 के सबसे पहले तो एकदम ही बीच में क्या आता है? 1 and 2 के एकदम बीचों बीच आ जाता है 3/2, which is 1.5. तो 3/2, can it be the correct answer to this side length? Sorry, 3/2. Could 3/2 be the correct answer? तो देखो बात कुछ ऐसा है कि if I told you that 3/2 is the side length, तो what would have been the area? अगर साइड लेंथ होता 3/2 तो what would have been the area?
9/4. A little more than 2.
3/2 into 3/2 करे हो गया 9/4, which is not equal to 2, है ना?
1.2.
ये तो थोड़ा सा ज्यादा हो गया 2 से, 2.25 हो गया इनफैक्ट.
Yes, sir.
क्योंकि 8/4 होता है एग्जैक्टली 2. तो 3/2 तो सही आंसर नहीं है. देखो एक चीज याद रखना, यहां पर जो भी साइड लेंथ होने वाला है उसको खुद से ही मल्टीप्लाई करेंगे तो 2 आना चाहिए. ऐसा हम लोग कोई नंबर ढूंढ रहे हैं. 3/2 से नहीं हो पाया काम. कोई बात नहीं, मायूस होने का तो बात नहीं है. वी हैव इनफाइनाइट ऑप्शंस टू चूज फ्रॉम. देयर आर इनफाइनाइट नंबर्स बिटवीन 1 and 2, इनफाइनाइट फ्रैक्शंस बिटवीन 1 and 2. तो आई विल गिव यू अनदर ऑप्शन 7/5. ये चलेगा?
नहीं सर.
क्यों नहीं चलेगा भाई?
5 का स्क्वायर.
तो 49/25 आया. 49/25 2 होता है क्या?
नहीं, 1 point something.
लेकिन बहुत क्लोज हो गया. देखो 49
Yes,
की
sir.
जगह न्यूमरेटर क्या होता तो 2 ही हो जाता.
50.
50 होता तो भाई काम ही बन जाता. 50/25 2 होता, लेकिन अभी थोड़ा सा कम हो गया है 2 से. लेकिन यू कैन इमेजिन if you were one of these ancient peoples, you will get excited that you're getting close to the answer, है ना? So you will keep going. I'll give you another good attempt. 17/12. Is this the correct answer?
No sir.
ये भी देखो 1 और 2 के बीच ही में है.
2 point something आता है.
12/12 और 24/12 के बीच ही में आता है. 12/12 is 1, 24/12 is 2, 17/12 इनके बीच में ही आता है. इसको अगर निकालेंगे तो कितना आ रहा है इसका स्क्वायर करने से? 17/12 into 17/12. तब एरिया क्या आएगा? 289/144. Is this equal to 2?
2 point something. More than 2.
More than 2. न्यूमरेटर क्या होने से काम बन जाता?
288.
288. Oh, so close, right? Because it is 289, and if it were 288 then it would have been, if you take a calculator and try to calculate what is 289 by 144 करके देखते हैं. 289 divided by 144, then that is 2.0069444. so close to 2. तब तो तुम लोग एकदम ही खुश हो जाओगे कि ऑलमोस्ट सर आंसर निकाल ही लिए हम लोग, है ना? x का वैल्यू इज वेरी क्लोज टू 17/12. हल्का सा छोटा करना है बस 17/12 से. 17/12 लिए तो 2 से हल्का सा बड़ा आ गया है. तो बताओ x में क्या फ्रैक्शन डाले? व्हाट मस्ट बी द एक्चुअल फ्रैक्शनल वैल्यू?
Sir, 16.9.
16.9. 16/9 you said.
Sir, 16.9 by 12.
16.9 by
12.
अच्छा, लेट्स ट्राई दिस. तो 16.9 इंटू 16.9 बाई 12 करके देखते हैं. तो 16.9 इंटू 16.9 कितना आता है? इंटू 16.9 It is this much divided by 144, तो इट इज कमिंग 1.98. फिर से तो चूक गया, अब तो ज्यादा छोटा हो गया. तो व्हाट
So
डू
we
यू
have to
वांट टू
find
डू?
the approximate value.
16.99 करना है. 16.99 into 16.99 डिवाइडेड बाई 144. थोड़ा और पास आ गया, पहले 2.0069 था, अभी 2.004 हो गया.
16.95.
So पहला बात, everybody has understood no what we have to do. We have to find this unknown value of x. The ancient people, being irresponsible ancient people, we have to now figure out कि भाई ये x कौन सा फ्रैक्शन होगा, क्या फ्रैक्शन वैल्यू होगा x का?
144 by 100. मतलब 1.4. Yeah,
144 by 100.
Yeah, around 1.1.
Around नहीं, we have to find exact. 144 into 144.
Sorry, not 144.
736 divided by 10,000 तो आ रहा है 2.07. ये तो बढ़ गया,
1.14.
ये तो खराब है इनफैक्ट. हाँ
1.14.
1.14
Yes, sir.
to 1.14. ये तो एकदम ही खराब हो गया, 2 से बहुत दूर है. I probably think what you mean is 1.414 into 1.414. So that is also not correct, but it is very close. A very, very good guess. 1.414. But this is also not the true correct answer, is it?
No, sir.
So don't feel bad, because let me tell you, although
Sir, I
people
want
were
to
very
just make
excited
one
when
more
they
guess.
faced this question, although they were very excited when they faced this question for the first time, कि अगर एक स्क्वायर है जिसका एरिया 2 स्क्वायर फीट है तो उसका साइड लेंथ निकालना है तो कितना होगा, तो उन लोगों को पता था कि भाई 1 फीट से ज्यादा होगा, 2 फीट से कम होगा. When they started putting fractions and they tried to guess what fraction will give 2 feet, तो अब ये जो हंट है ना, the hunt of a fraction between 1 feet and 2 feet which once multiplied to itself gives exactly 2, ये हंट सालों साल चलते चला गया. ठीक है, इट माइट बी सरप्राइजिंग टू यू कि ऐसा नंबर फ्रैक्शन मिल क्यों नहीं रहा है. बट यस, टेल मी व्हाट इज योर डाउट.
Sir, how do they know the area is 2 feet square if they don't know the side length?
No. Area is already measured. Area they know is 2 square feet. That can be done in many ways. Okay, the area can be set in many ways. Maybe they knew the area of something. Maybe they knew the area of the 1 square feet tile and they are breaking tiles and see how many tiles have fit inside this big square. So they are seeing 2 tiles have fit. So that is how they know that the area is 2 square feet.
Oh, okay.
Okay. So if you know that the area is 2 square feet, then what will be the side? So let me already give you a spoiler. सालों साल, in fact more than 100 years were spent to try to find a fraction that lies between 1 and 2, which once multiplied to itself gives 2 square feet as the answer. मतलब 2 as the answer. But sadly कोई भी वैसा fraction नहीं मिल पाया.
Sir, can't we just measure it with a ruler or something like that?
You can try, but फिर इतना precision से कैसे ही निकलेगा? अभी if you really draw a square that has an area of 2 square feet and you use a ruler, अब ruler का तो एक limit है ना, there is a certain least count for every measuring device. If you stand on a weighing scale, if I stand on my weighing scale, it shows that I am 82.5 kg. अब इसका ये मतलब है क्या कि my weight is exactly 82 kg and 500 gram. ऐसा भी तो हो सकता है ना कि it was 82 kg 503 grams. It is the limitation of my weighing scale that it only measures up till 1 decimal place. So using measurement we cannot calculate the exact value of the side length because we are limited with the accuracy of the measuring device. Right? So we have to calculate it mathematically. यहीं से there came a wave of mathematicians that said कि भाई वापस टाइम आ गया है. किस चीज का टाइम आ गया है? नए नंबर्स इन्वेंट करने का टाइम आ गया है कि ये जो साइड लेंथ है इस स्क्वायर का जिसका एरिया 2 स्क्वायर फीट है, ये अभी तक हम लोग जितने नंबर्स जानते हैं उनमें से कुछ है ही नहीं. बट जैसे ही मैथमेटिशियंस ये बात बोलना शुरू किए, जो दूसरे मैथमेटिशियंस थे जो कह रहे थे कि भाई तुमको ऐसा क्यों चाहिए नया नंबर, 1 और 2 के बीच में तो हम लोग इनफाइनाइट फ्रैक्शंस निकाल के रखे हैं, उन्हीं में से कोई एक होगा ना आंसर, इनफाइनाइट चॉइसेस हैं, ढूंढते रहो कभी ना कभी तो मिल जाएगा. तो एट दैट पॉइंट द होल मैथमेटिकल सोसाइटी and the family of mathematicians got split into these two groups. Okay, one said कि कोई ना कोई फ्रैक्शन तो मिलेगा 1 और 2 के बीच में जिसको खुद से मल्टीप्लाई करेंगे तो 2 आ जाएगा, यानी जिसका स्क्वायर करेंगे तो 2 आ
Sir, is the
जाएगा.
answer 1.41?
नो, इट इज नॉट 1.41. और जो दूसरा ग्रुप ऑफ मैथमेटिशियंस है वो बोलने लगा कि भाई जितना लाख कोशिश कर लो ढूंढ लो, बट 1 और 2 के बीच में ऐसा कोई फ्रैक्शन नहीं मिलेगा जिसको स्क्वायर करके एग्जैक्ट 2 मिले. अब तुम लोग किसके साइड में हो?
Sir, दूसरे.
अब तुम लोग तो दूसरे के ही साइड में हो गए क्योंकि तुम लोग रूट 2 के बारे में सुन लिए हो, 2025 में जी रहे हैं, तो तुम लोगों को तो पता ही है कि रूट 2 एक नंबर है. लेकिन उस समय के लोगों को पास ऐसा कोई नंबर नहीं था. लेकिन सवाल बड़ा जरूरी खड़ा ये हो गया था कि ऐसा कोई नया नंबर बनाने का जरूरत है या इन्हीं फ्रैक्शंस में से कोई एक ऐसा नंबर है जो इस साइड लेंथ के एग्जैक्ट लेंथ को जस्टिफाई करेगा. प्रॉब्लम समझ में आ रहा है?
Yes, sir.
एक मैथमेटिशियन उनमें से था डिकार्टस. ठीक है, डिकार्टस. After this long debate of whether there is a fraction that lies between 1 and 2, which once squared gives exactly 2, या which once multiplied with itself gives exactly 2, this debate was very long. Descartes was a mathematician who for the first time proved the fact that it is impossible to find a fraction that lies between 1 and 2 which will square to give 2. वो प्रूव ही कर दिया, मैथमेटिकली प्रूव किया. Now it is, of course, तुम लोग सोच रहे हो कि किस तरीके से प्रूव किया, वो भी हम लोग डिस्कस करेंगे. पहले तो मैं तुम लोग पे छोड़ दे रहा हूं. लेट मी ऑलरेडी टेल यू दैट तुम चाहे लाख कोशिश कर लो, क्लोज भले पहुंच जाओगे, यू विल नेवर बी एबल टू फाइंड अ फ्रैक्शन दैट लाइज बिटवीन 1 and 2 which multiplied with itself gives exactly 2.
Sir, I want to give one last try.
Yes, please try.
1.414141 like this.
नहीं हो पाएगा. 1.414141 कितना लिखना है और बताओ.
Sir, you have to write infinite 414141.
Then it is not a fraction actually. Then it is not a
irrational
fraction. If you write
numbers.
it infinite times, then it is not a fraction anymore. Okay.
Sir, 1.
Hmm.
Sir, 1.41421.
See, whatever you do, 1.41421, you will only reach close. देखो और close पहुंच गया 1.9999. But you will never reach 2. So don't. I am saving your time. Don't try to find, because Descartes has proven it. But let me also tell you a sad story. Back then, it's quite interesting to see the history of how science and maths have evolved. Science and maths was very heavily mixed with religious beliefs. So when Descartes proved that there cannot be any fraction between 1 and 2 which squares to give 2, he was actually on a ship, मतलब boat, large boat. So the other mathematicians who were very religious believed that he has broken the logic of maths. Because they were simply thinking कि भाई जब infinite options था तो अचानक से ये बात कहां से आ गया कि इन infinite options में भी कोई भी ऐसा fraction नहीं हो सकता which exactly squares to give 2. So at that point Descartes was thrown out of the boat and killed. Okay, and it is only through his disciples that we know that Descartes had made the proof that there cannot be any fraction between 1 and 2 which squares to give 2. Okay, and of course the disciples brought forward the proof for the rest of the world to see, and it's a very beautiful proof. But before I tell you what the proof is, I recommend strongly that all of you think about how you could prove that there cannot be any number between 1 and 2 there cannot be any fraction between 1 and 2 which multiplies to give you 2. which multiplies with itself to give you 2. Okay, understood? This is your homework, first homework. Also, one more thing, the numbers that have been invented so far are said to be rational numbers. ये जो family of numbers है ना, they are said to be rational numbers. Why are they said to be rational numbers? Because all of them can be represented as a ratio of two numbers. The word rational comes from which word? Ratio. तो अभी तक जितने भी नंबर्स हम लोग लिखे हैं ना, दे कैन बी रिप्रेजेंटेड एज अ रेशियो ऑफ टू नंबर्स. कोई भी नंबर पकड़ लो, फ्रैक्शन पकड़ोगे तो वो तो दिखाया ही जा रहा है एज अ रेशियो ऑफ टू नंबर्स. 5:2. 5/2 इज 5:2. अगर बोलोगे 6 तो इट कैन बी रिटन एज 6:1 या 12:2. मेनी वेज. बट डिकार्टिस को यह शक हो गया था कि दिस क्वांटिटी इज नॉट रैशनल. इट कैन नॉट बी शोन एज अ रेशियो ऑफ टू नंबर्स. बट यही बात तुम लोग को प्रूफ करना है कि ये जो लेंथ है ये कोई रैशनल क्वांटिटी है ही नहीं. दिस कैन नॉट बी शोन एज समथिंग डिवाइडेड बाय समथिंग. वही बात है ना, इट कैन नॉट बी शोन एज सम फ्रैक्शन. दिस इज व्हाट यू विल हैव टू ट्राई टू प्रूव बाय योरसेल्फ. एंड दिस वाज द इन्वेंशन ऑफ इररेशनल नंबर्स. डिकार्टिस इन्वेंटेड इररेशनल नंबर्स. वो बोला कि इसका जो आंसर है, अभी तक जैसे इंसान नया नया नंबर्स निकालते आया ना, जब जीरो का जरूरत पड़ा तो एक नया सिंबल लगा दिया, फ्रैक्शंस का जरूरत पड़ा तो एक ये नया टाइप का रिप्रेजेंटेशन निकाल दिया, जीरो से छोटे नंबर्स का जरूरत पड़ा तो एक और नया रिप्रेजेंटेशन निकाल दिया, ये डैश लिखने लग गया नंबर्स के आगे. वैसे ही अभी भी जब एक नए टाइप का नंबर समझ में आया तो फिर क्या टाइप का फिर से नया रिप्रेजेंटेशन आया. क्या आया? ये वाला सिंबल. इट इज नोन एज द स्क्वायर रूट सिंबल. तो बोला डिकार्टिस की आंसर जो है ना ये साइड लेंथ का, उसका आंसर है √2. और सिर्फ यही एक सही आंसर है, और कोई आंसर नहीं है इस साइड लेंथ का. इस बात को तुम लोग अच्छे से समझो. नाउ यू पीपल आर इन क्लास 8, यू विल हैव टू एक्सेप्ट √2 एज अ नंबर. जैसे 5 एक नंबर है वैसे ही √2 भी एक नंबर है. ठीक है. People back then had a lot of trouble trying to accept √2 as a new kind of number. बट जितना 5 एक नंबर है, जितना 0 एक नंबर है, उतना ही √2 भी ठीक उसी दर्जे का नंबर है. ओके, यू हैव टू एक्सेप्ट √2 एज अ नंबर.
Sir, did Descartes also meant plus minus √2? Like
No,
we
so
say
length is not going to be negative. The length is not going to be negative. So therefore he simply said that.
But Descartes did
See, if let me tell you.
Descartes invent that?
हाँ, if negative numbers are invented, then the moment √2 is getting invented, automatically minus √2 is also getting invented. जितने जैसे फ्रैक्शंस पहले से इन्वेंटेड थे, तो जब नेगेटिव नंबर्स इन्वेंट हुए तो नेगेटिव फ्रैक्शंस भी साथ ही साथ इन्वेंट हो गया. ठीक है. तो उसी तरीके से when √2 is getting invented, minus √2 is also going to be a number. Okay. But obviously the point is to first, before we accept √2 as a number, we have to agree कि is this quantity really irrational. क्योंकि तुम एक बात सोचो, अगर दुनिया में irrational quantities नहीं होंगे, if there are no need for irrational numbers, then why would we go ahead and call some number rationals? जरूरत ही नहीं है कि इन नंबर्स को रैशनल बुलाने का. Only when there will be some numbers that are irrational would it make sense to call some numbers rational. है कि नहीं? In your class or in any set, the other set only exists because of the first set. What I mean to say is, as a very simple oversimplified example, there some people can be called good only when there are bad people. If nobody is bad, then it would make no sense as to who are good people. उसी तरीके से the name of your chapter is rational numbers. The name of the chapter only makes sense only if there are some numbers that are not rational. बट इसी बात को हम लोग को पहले प्रूफ करना है कि हाँ भाई, ऐसा भी क्वांटिटीज हो सकता है जो कि रैशनल नंबर से एक्सप्रेस ही नहीं कर सकते हैं. Okay.
Sir, can't we write 1.1414 414141414141
414141. हाँ ठीक है. If you write 100 times and then you multiply it with itself, then also the answer is not equal to 2.
Sir, infinite times.
If you're writing infinite times, then it is not a fraction. That is the thing. ठीक है. By the way, I will prove to you that if you write 1.4141414141 infinite times, actually if you're writing 4141, then it is a fraction. If you're repeating the same set of number, you are saying that this you want to write, right? 1.41414141. This is your expected value of x. मैं prove करूं कि this cannot be the correct answer. You tell me what will be the value of 10x. Gaurav.
14.14141414.
14. हाँ. And tell me what will be 100x.
Sir, 141.414141. Sir, I am doing exactly that right now. And the answer is 140 by 99.
So we can do x and then we can subtract 1.414141414141 and then we are getting 199. We are subtracting both sides, 140. So we are getting 140 by 99. Now if you do 140 by 99 into 140 by 99, कितना आ जाएगा? Numerator will be what? 19600. Denominator will be what? 9801. ये 2 हो गया क्या? नहीं हुआ. 9801 का डबल 19600 नहीं होगा, वो 19602 होगा. तो फिर से चूक गए. Are you understanding, Gaurav?
Yes, sir.
So don't worry, Descartes is right. I'm already telling you that. So you can end your endless pursuit of that number, of that fraction. Rather you can start thinking about how will you actually prove कि ऐसा कोई number हो ही नहीं सकता है 1 और 2 के बीच में, which you will square to get 2. That is the more important thing to do now. Okay. Alright, so this was the introductory class to rational numbers, where I have first tried to explain the family of numbers. Okay. And why the name of the chapter makes sense, rational numbers. Next class, we'll start discussing about the operations of rational numbers. Okay, addition, subtraction, multiplication, division among rational numbers, the different properties of operations, closure property, distributive property, commutative property. Okay. Alright, chalo. I'll see all of you in the next class then. Bye bye.
Bye, sir.
Bye bye.
Bye, sir. Thank you, sir.
Bye.